transform how we Our Python Essentials for MLOps, DevOps, and AIOps course will unlock the secrets of streamlined development, intelligent automation, and efficient operations. As you progress in your learning journey, you'll be mastering the Python fundamentals, discover the file automation strategies, conquer the command line with ease, and even deploy the infrastructure like a pro. And this curriculum has been carefully designed so that as a learner, you'll be learning everything in a hands-on manner. This will unlock your potential in building the practical tools, scripts, and the pipeline that will amaze your team. You'll be diving into the package management, Docker, CI/CD workflows, and even the AWS fundamentals that will make you to be confident in implementing everything over the cloud. To take your skills to the next level with in-demand expertise in MLOps, AIOps, and even you'll also get a bonus content on the monitoring the applications as well. So by the end of this course, you won't just use technology, you'll own it. So stop struggling, start excelling, and upgrade your career. My name is Murthy from Manifold AI Learning. I Hey everyone, welcome to this session on MLOps. I hope you can hear me now. Can you please confirm? Perfect. Okay. Thank you, Abhishek. Thank you, Rakshit. Okay. Thank you so much, everyone, for joining in. And I welcome you on this MLOps projects live session. So, folks, the code trailer that you have just seen few seconds back, that's the latest course from Manifold AI Learning. So, as you know, this session is made possible from the team at Manifold AI Learning. So, if I want to give some information about Manifold AI Learning is a company who's into the who's into the providing the self-paced courses on various topics related to data science, machine learning, MLOps, LLM ops, and the generative AI. The course trailer that you have just seen, it's part of the latest course, which I've got a chance to create with them. That's Python programming for DevOps MLOps engineer. Now, this is a course which has been created very recently, and it is scheduled for the completion this week. And I just want to give you a quick update on the overall course. So this course consists of various units that is there for you to master the Python programming for MLOps. So one of the common issue and the query that I've seen is how do I prepare myself in this Python programming, because Python is a dynamic programming language and can be used for various activities. So to address the specific topics from the DevOps and the MLOps perspective, this course has been created where you'll be mastering the Python fundamentals. You will learn about the Python file automation, how to work with the command line, and you will learn about the Linux utilities with Python, how to perform the package management with Python, Docker for DevOps, MLOps, AIOps, how to work with GitHub Action. You'll also understand how to work with AWS, and you would go ahead and create a CI/CD pipeline with GitHub Action uh, where you will create a Python project, perform the commit to your GitHub repository, and you will deploy that application on the EC2 instance. And you will also learn about the PyTest module, which is one of the important module when you're building any MLOps project. And you'll also look into a demonstration of the MLOps project, how to manage the infrastructure using Python. And as a bonus, you'll also learn about the Prometheus and Grafana, which will help you to monitor your Python-based application. So this course has got more than 16 hours of learning content. And let me tell you, this is the early release price. So the course is expected to increase. Course price is expected to increase. So I'm sharing you the link over here in the chat window. Do check out the link and register yourself so that you will be logged into this early release price. Now, if you're someone who has been already part of the generative AI package of Manifold AI Learning, you don't have to purchase. This course is already part of your Mastering Your Generative AI in 2024 package. Okay, I'm sharing you those link as well over here in the chat window to check out, guys. Now, let's come back to our discussion and let's look into our topic of today's session, that is the MLOps project implementation. In the last session, what we have done till now is we have looked into the two important aspects. One, we have learned about the basics of the experimentation. We have taken up a task of the classification where we have picked up a data set that's called as the online foods data set. Now, on this online foods data set, we went ahead and implemented a classifier. Now, the next step that we have also learned is we have learned some of the basics of building a package. Now, what we'll be doing as part of our today's learning journey is whatever the code that we have written till now, we would go ahead and create the modularized code approach. Now, this is very much essential for our learning journey. The reason because once we have the modularized code approach, it will be easier for us to maintain. So it's very important that we maintain this approach and we maintain the modular coding approach. And I'll show you what are the files that you'll have to mention, like how do you go ahead and create everything. And we'll be doing it in a hands-on manner where I'll be typing the code and explain the importance of each and every step. So that's how we'll be progressing in this learning journey, guys. Now, before we get started, guys, do you have any questions from the learning that you had till now? Okay, let me remind one more thing. I think I'm getting queries on how do I access the previous session recording. So you can access the previous session recording by visiting the manifoldailearning.in, and over here click on courses, and there's a course on MLOps project live end-to-end workshop. So I'm sharing you that link here. You can go ahead and check out this link for accessing the sessions recording. Okay, so all the sessions recording and even the previous sessions attachment, everything will be made available to you in this overall interface. Okay, guys. So any other questions, team? So folks, if you are good to start, please confirm by typing in as good to start in the chat window so that we'll get started with today's agenda. Thank you, Lakshman. Thank you, Swati. Thank you, Dheeraj. Thank you, Samyukta. Okay, excellent, guys. Thank you so much, team, for your confirmation. So let's proceed ahead in our learning journey right now. So here, as I mentioned, we would go ahead and create the uh, create the modularized code approach for our implementation for this data set, that is online foods data set. So let me do one thing. So let me just clone my repository. So I don't have this repository in this new system which I'm currently working with. Let me do a quick cloning, and from there it will be easier for us to, for me specifically, to get started. Okay, I've cloned this repository. So if I open up my VS Code, I'll just open that folder. So the place that I have cloned this repository is this. So this is the folder where we have from the previous session. So we've got a data set that is onlinefoods.csv. Now let's start with the overall activity of creating a package. Now we have learned already as how we can create a package, but the important thing is how do we approach this package creation for an MLOps project? So I'll be mentioning over here in the same repository, and as and when it is required, I'll be creating a new repository for the separate demonstration. So I'll mention our second step of our learning journey, that is packaging the ML model. So that's the second step. So let's go ahead and create the package. Now inside this, I'll create one more folder. So this folder, I'll be just mentioning all the files, everything that is required. I'll be mentioning over here inside this folder. So maybe I'll just mention as model packaging. Okay. Now let's go ahead and create a folder structure. Now inside this folder structure, you are already aware about the various files that we need to build. So if I want to create it as a package, okay, the important file in the root directory is setup.py. So that's the file that I want to create. And apart from that, so if I'm working in any environment, so I want to take care of the dependencies. So I'll have to create this requirements.txt file, and we can create the any manifest file as well, which will tell the package to be included. Maybe we can add it at a later point. So these are the two files that I've added, that is requirements.txt and the setup.py. And apart from that, the overall important model contents that I want to create, I would go ahead and mention it inside a folder. So I'll just call it as prediction underscore model. So that's the model name that that's the overall package name that I'm going to create. So we'll use this prediction underscore model. I'll do one thing. I'll say prediction underscore model underscore manifold live. Okay. That's the package name that I'm going to create. Now inside this package, we'll have to configure the various file. So inside this package location, first thing that I'll do is to be able to access it, I'll say underscore underscore init.py. So if I want to make any module available, I'll have to mention those details inside this init.py file. Maybe we can complete it at a later point. Okay, next, apart from this, uh, I'll do one thing in the same location. I'll create one more folder for my data sets. I'll say data sets as one more folder. And whatever the pre-processing that I'm going to do, I'm going to place those files under this pre-processing folder. Then when I perform the training and save the model, I'm going to save it under this trained underscore models folder. This is the location where I'll be saving it. Now, in order to perform the training, I would go ahead and create one more Python script. I'll call it as training pipeline.py. Okay, so this is one thing that I'm going to do. And maybe if I want to create the pipeline separately, so if I want to create it as a single pipeline which has got multiple steps and I want to import it in my training pipeline, so I can go ahead and create one more file called pipeline.py. So this is another file that I'm going to create. So currently I'm just going to create the various files, guys, and we will use it. We will first, once we create the structure, then we would go ahead and fill those entries over here as per our project. I'll create one more Python file, that's the predict.py, which would help me to run the prediction. Now to be able to access the data set, so I'm going to go inside this folder and I'll say underscore underscore init underscore underscore dot py, and I'll do the same thing for my pre-processing folder and the train models folder. Okay, now each and every folder have got the various like the init.py to ensure that we are able to import it in our package. And the another thing that I'll do is I'll create one more folder, which I'll call it as config. Okay, and inside my config folder, I'll place one more file, that is underscore underscore init underscore underscore dot py, and I'll create one more Python file over here inside this config folder, which I'll call it as config.py. Now this config.py will contain all the necessary configuration for my MLOps project. So if I expand my current data structure, like the folder structure, this is how the overall folder structure would look like. We've got our data set, and we have like there's a data set folder, there's a configuration folder, and there is a pre-processing folder, there's a trained models folder, and we've created the Python script for pipeline, predict, and the training pipeline. And there's a text file which is called as the requirements.txt and the setup.py, which is at the root location of my package. And the package name that if we have decided to keep is, it is prediction underscore model underscore manifold underscore live. So that's the name that we have specified right here. Okay, now let's do one thing. Let's populate the data set. Since we have the data set with us, I'll just go ahead and copy this data set and paste it over here. So this would help me to have the data set in my data set folder. Okay, so this data set is ready. Then what we will be doing is wherever we require the configuration, we'll have to populate it inside this config.py. Now, let's let's go ahead and let's start filling those various details. Okay, so in my config.py file, so we are going to set the overall folder structure. Okay, we are going to set the overall folder structure. So before we do that, let me do one thing. Let me start getting the other files and we'll start populating it. Okay, so let's start by creating the training pipeline. So as and when we would require, we are going to fulfill those things. Okay, we'll build it in that way. Since each and every file is like I can say, since each and every file is very important for us. So we will configure multiple files. Just be with me. So by the end of this overall activity, you'll get a clear picture. So I'll be working with multiple files together so that we'll get a better idea as how it actually works. So I'll start by importing the pandas library since the training is what I'm trying to do. So I'll start by importing the data set. To import the data set, which is in CSV file, I'll be requiring the pandas library. So import pandas as PD, and we'll also import the NumPy library. And then here, I have mentioned that to load the configuration, I'll be making use of this config.py file. So if I want to load that configuration.py file, I'll have to load my package. I'm going to say prediction underscore model underscore manifold underscore live. I'm going to import the config module. Okay, I'll be importing this config module. So, uh, when I say config, this is what it will be loaded right here. Now, as and when I would require, I can, okay, I'll have to say dot config import config. So this is the config is the subfolder name and config is the Python module. So I'll import this configuration file, and then I'm going to say from prediction model manifold live, I would go ahead and uh, import some pre-processing. I'll say dot pre-processing. Okay, we'll have to import a module. So let me go ahead and create a module inside this pre-processing so that we'll have it as an identifier for us. So inside this pre-processing folder, I would go ahead and create a file which I'll call as preprocess.py. So I'm going to say from dot pre-processing, I'm going to import pre-process as pp. Okay, so for performing the pre-processing, I'll make use of the shorthand notation as pp. Now apart from that, so let's do one thing. So here under this pre-processing, in order to load the data and if I want to save any pipeline, I'll be mentioning it inside this pre-processing folder itself. So for handling the data, I would go ahead and create another module called data handling. This is another module that I will create and I'm going to import it in my overall training pipeline. So here I'm going to say dot pre-processing import data underscore handling. Okay, so this is what I'll be importing right here. Now, once I import this data handling, so then what we'll be requiring, okay, so let's consider it, okay, from the configuration file, the overall thought processes, I'll be getting all the necessary configuration values, the static values, whichever I would require, I'll be reading it from the configuration file. Now, based on those static values, I would go ahead and load the data set using the data handling function, perform the pre-processing as per the pre-processing modules that I'm going to create. Then the next logical step would obviously be instantiating my trained model. So let's say if I've got a trained model, I want to go ahead and instantiate my trained model. That means load my trained model. And after loading my trained model, I'll have to go ahead and generate the prediction. So that means my next step would be, I would say, loading my pipeline itself. Okay, let's go ahead and load this training pipeline. So I'm going to say from prediction model underscore manifold live dot pipeline. Okay, so I'll go ahead and okay, this is basically from here. I'll say import manifold AI learning model manifold live as pipe. So I'm going to import this pipeline module that I have got right here. Okay. So this is what I'm going to import. Okay. So like let's for the first like just for now, let's assume that everything that we are trying to import is working as per expectation and there is someone who has already written the code. Now with that assumption, let's go ahead and let's try to complete it. I will also go ahead and import the system module. Now to perform the training, I would go ahead and create a custom function called perform training. Okay, when someone calls this perform training, the first thing that I'll have to do is I'll have to go ahead and load my data set. I would say train data is equal to, so to load the data set, I'm going to say data handling dot load data set. I'm assuming that there is a method that I'm going to create, which I'll call it as load data set. And that would help me to load my data. So I'll say config dot data set, or I'll say train data set. Okay. So this is what I would create, or maybe I'll make it as train file. Okay. So like from here itself, we need to remember that we need to create load data set method. Okay, let's make some notes so that we can check out over here and then we can go ahead and complete it as and when we progress. And we'll also have to create this train file in config. Okay, so this is what I'm going to do. This is going to load the data set. Then what I'm going to do is I'll have to get my y. I'll say train target. Okay, I'll say train target. To get my train target, whatever the training data that I'm going to get. So from there, I'm going to extract the target column. Okay, I'll extract this target column and we can go ahead and perform some activity. In our case, I think the, I believe the target is basically the positive, I believe. So let me do one thing. So let's have a quick check into our data set. And from there, we can have a quick look into the same. So the output is the column, which is our target. Okay. So that's what we are going to get. And there are yes and no values. So what we can do is whenever we are loading this data set, we can load that panda series, that is my single column, and then we can map those values, guys. So let's go ahead and do that. So I'm going to say dot map, and let's map it right away. So in order to map it, I'll make use of my Python dictionaries. So for yes, I'll say it as 1, and for no, I'll mention as 0. Okay, so let's ensure that the cases are matching. Yes is 1, for no, it is 0. Okay, in this way, we would go ahead and perform this mapping. Now, once the mapping is completed, here, in this case, we have loaded the pipeline. So what we are going to do is from this pipeline module, let's say we are going to load an object called the model, that is my trained model that I've got. So I'm going to say pipe dot classification model that we have got. On that model, I'll go ahead and perform the fit. So in order to perform the fit for my training data, I would go ahead and maybe I'll load my input features, and then I'll specify my train target. So in this way, I'll be specifying my features and target. So let's make some notes over here, which will be uh, considering it in the other files that we are going to create. So in the configuration, we'll have to mention what exactly is this target value. That's important, else this is going to fail. And another thing that we have to ensure is create a model pipeline in a pipe in pipeline module, and also configure features in config. Okay, these are the two things that we have to do. And once that is done, so if I want to perform the saving, so what I'll do is under this data handling itself, I'm going to create one more function, which I'll call it as save pipeline. And using this, I'll go ahead and save my pipeline. So I'll just go ahead and mention my pipe.classification model, and this should be able to save this model. Now, once that is done, so I think this will complete the training. So I'm going to mention the additional details. I'll say if underscore underscore name underscore underscore equal to underscore underscore main underscore underscore. So with this condition, so the reason that we specify this condition, because we want this function to be called whenever whenever this Python script is run. Okay, so whenever this Python script is run in the command line interface, we want the perform training should be executed. It should not be executed just someone is performing the import. It should not be doing it. It should be executed only when someone is executing it. So that's the overall expectation here, team. Okay, so that's the overall expectation, guys. So yeah, so okay, just give me a second. Okay, okay, I'm now seeing some updates over here on the other channel. Okay, thank you, Dasun. Thank you, Muhammad Abdul. Okay, I think I have answered now. So Abdul, have let me confirm you. So for folks, there are a few queries on the LinkedIn channel. Let me just answer the same, folks. Okay, so let me share the link that has been requested. The previous session's recording, I've just shared it over here on the LinkedIn as well. Okay, so let's come back, guys, and let's proceed ahead in our learning journey. Okay, so let's come back to our code that we have got. So here we have mentioned that it has to perform the training. So when someone calls this training pipeline, so we have just mentioned that, okay, it has to perform the training. Now that this is clear, so let's proceed ahead and create the other stuff. So one thing is, okay, so we can now go ahead and proceed with the creation of our configuration file and the other files as and when it is required. So
let's do one thing. Let me just start by creating this configuration file, and from there we would get started. Okay, so here, if I come over here in my configuration file, so first I'll go ahead and import the necessary module. I'm going to import the pathlib. I'll import the OS, and I'll import our package itself, that is prediction model manifold live. Now, then what I'm going to do is I'm going to specify my package root. So package root is nothing but where exactly is the root folder of this package. So for that, I'll say pathlib dot path, and I'm going to get the path of my package dot underscore underscore file. Okay, so for this file, I'll go ahead and get the parent. So in this way, we would go ahead and get the package root. Next, we would go ahead and mention as how the system should look for. See, inside my packaged home directory, that is this prediction model manifold live, inside this, if I want to get the data set, so I'll have to go inside the folder of data set, and from there, I can access the file. So I can say my data path is basically, I'll have to say os.path.join. It has to be joined with my data sets. Okay, so this is the next step. Then I would go ahead and mention my training data. So just for the demonstration, okay. So what I can do is we'll do one thing. We'll just remove few entries from the training data and we'll make it as a test data. We'll do this manual activity since we are using it for our personal learning. Let me just modify it right away. So under this data sets, okay, so what I'll do is this is my test data. Okay, on my test data, I'm going to, this is my training data. So on my original data, I'll do one thing. I'll remove, let's say, from till row number 300 over here. I'll just keep it in my training data and I'll keep the remaining ones in my test data. Okay, so first 300 rows, I've made it as a training data, and the remaining values from 300, I'll keep it as a test data. So I'll just drop everything now. So I have these many entries for my test data. So we'll just rename the file. I'll call it as train underscore data.csv. And the other file, which I'll call it as test underscore data.csv. Okay, so I've got two files now. One is my training data and the other one is my test data. So once I have these files, so let's go ahead and continue to specify our configuration file. So from the data path, that means if someone goes inside this dataset folder to be able to access my dataset.csv, I'll just have to mention the train file. Let's check. Okay, it is a train file. So I can say train file is equal to, what is my file name? It is train underscore data dot csv. Okay, this is what I would specify now. In the same way for test data, since we have added one more data, I'll call it as test underscore file and I'll call it as test underscore data dot csv. Okay, so with these values, if I come to my training pipeline, so if someone is trying to call this config.train file, so he or she will be able to get the file name, which is basically my train file, training data, that is train underscore data dot csv. That is what he or she is going to get. Okay. Next, what we can do is we can also mention the target. That's an easier one. let's go ahead and mention the target. In order to specify the target, I'll say target is equal to, okay, and we'll have to specify the output column name. The output column name for the target is the output. Okay, so this will be my output target name. Then we can go ahead and specify our features. What are the list of features that I want to get? So for the list of features is basically the features that I've created right here. And for the list of features, we just have to list down the features that we have got. So in my case, let's do one thing. Okay, I'll quickly get the list of column names that we have got so that we can use it for our working. So I'll just regenerate. The reason because like I don't have the access to the previous notebook. So for now, we'll just proceed ahead. Okay, so we'll just quickly get the required values from here. So this is the list of features that we have got. In our case, the complete list of features which are relevant for us are these, like age, gender, marital status, output. Output is the one that we are going to consider. Okay, and feedback. Let's consider the feedback as well. So, okay, now this raises the question, guys, whether we are like, this is an important question that we need to ask. So here in this data set, if you observe, I've got one more column that's called as unnamed 12. Now, this is the column that we see right here. And for this column, okay, for this column, this exists over here in the data that we have got. Now, the question that we need to ask is, okay, this is an incorrect data that we have. Now, is this data, is it specific to our training example, or is this a common in the production scenario as well? So based on the answer to this question, our code is going to vary. So in our case, obviously, let's us assume that this entry has been captured only because of our the error in the data collection. So I'll proceed with that assumption. So with the, if that is my assumption, then when I'm creating the code, I'm going to ignore this column itself. I'll ignore this column altogether. I'll not consider it for our processing. So I'll consider the remaining columns, whatever the columns that I've got. So I'll consider everything over here and I'll mention it as the features for my given data set. I'll ensure that the output column is not part of the features. So this features is basically a Python list which has got the complete list of features that we are going to consider for our model training. Now, obviously, when we load the set of features, we'll have to perform the pre-processing, and that's where the pre-processing module that we are going to create will take care of it. So I hope you are able to follow along with me. So here we have created the features and we have mentioned the target. So basically, I would say by looking at it, so we have completed the overall things that we need to maintain over here, especially for our configuration file perspective from the training pipeline. All right, guys. So let me do one thing. Let me commit these code changes to repository, and I'll be sharing you the code. So if I refresh the code repository, so here you can see a new folder called packaging ML model, and you'll be able to see the various files that we have created, that is training pipeline and the configuration file created over here in the GitHub repository. So I'll share you the link, guys. Please go ahead and refer to the link. and let me know if you have got any question. Okay, I've shared you the link in the live chat as well. So please refer to the link and let me know if you have got any question. Now, if you're clear, so please confirm by typing in as all good. So team, I'll give you a few minutes. Just have a look into the same and let me know if you have got any questions. So team, are we good to proceed with the next module? Please confirm. Okay, thank you, Dheeraj. Thank you, Rakshita. Thank you, Sridhar. Thank you, Samyukta. Thank you, Lakshman. Thank you, Mohammed. Okay, excellent, guys. Thank you so much, team, for confirming. So let's proceed ahead. Okay, so let's go ahead and continue with our coding. Now, we can start by, let's say, let's come back to our code. Okay, now let's review. So what we have done is we have taken care of this configuration file. So we still have a long way to go. We'll still have to mention a few more things as well. But for now, from the look of it, there's training pipeline. So we have done with the configuration. Now let's go ahead and implement this data handling, which is the methods that we have got, that is load data set and save pipeline. So this load data set is going to get the file name, so which means I'll only get the file name. It is my responsibility inside the function to get the complete path. So let's go ahead and create the same. So I'll open this data handling Python script. So I'm going to import the OS module, will import the pandas library, and I'll import the joblib library. So the reason that I'll be using this joblib, because this would help me to perform the activity of serialization. You have already learned about the serialization in the experimentation session. So this would basically help me to perform the serialization. That means save it into an external file. Then I'm going to save from prediction model manifold live. I'll go ahead and import my configuration module. Now to load the data set. So here I'll create my custom function, which I'll call as load dataset. And this is going to get the file name. Okay, because we were just getting the file name over there. Now what we will do, we'll get the file path. So to get the file path, it is basically os dot path dot join. I'm going to join the data path that I've got with my file name. Okay, this will get the complete path. Now, once I've joined it, I'm going to load the data set. So pd dot read underscore csv, and we will load this file path. So this would help me to load this data as a data frame, and this is going to return the data. So as a result of this, when someone calls this load dataset function by specifying the file, the trained data is basically a data frame which contains the data from the trained data.csv. Okay, that's what it's going to happen. Now, after that, we are going to separate it. Now, once we did the separation, here we are going to train the model. So after that, we have created one more code, which is a save pipeline. And this is also part of the data handling. So let's go ahead and perform this activity of save pipeline. So I'm going to say def save pipeline, and this is going to get the pipeline to save. Okay, I'll receive the pipeline that I want to save. I'll get the path. So that means where exactly that I want to save. So here, I think I'll have to specify a new path. For now, I'll specify the value, and we will have to configure it inside this configuration.py file. So os.path.join, and here I'll get my model save path, comma, and I'll also get my model name. That means in which name that I want to save. Now, once I have the complete details, I'll say joblib.dump, and I'm going to specify my save path. And so I'll also have to specify the model that I want to save, that is pipeline to save on the required path. Okay, maybe we'll provide some confirmation message that says as model has been saved under the name. Okay, maybe we can go ahead and specify the model name as well. We can simply say config.model name, and this is going to display the model name. So let's do this then and there itself. So one is a model save path. So we'll come over here. The model save path is basically, so from my package root, okay, from the package root that we have got. So we'll have to save it inside this trained and underscore models. Okay, that's the model save path that I'm going to specify. Then for the model name, let's go ahead and mention the model name. I'll say model name is equal to classification dot joblib. Okay, because this is a classification activity, I'll say classification underscore final. That's the name that I want to give. So from here, it will get the model name and it will save this, and joblib.dump, it's going to save that model, and we are just going to print the model name. Okay, that this will take care of the serialization process. Okay, now once the serialization process is completed, so obviously we'll have to generate the prediction in future. Let's go ahead and specify those function as well, which would actually help us to perform the deserialization. So this is going to take care of serialization, and I'll go ahead and create one more function for the deserialization. Def load pipeline. And here I'll have to specify the pipeline to load, okay, where someone will specify it has to load there, how they want to load the pipeline. So I'll get my saved path. which is basically my model where exactly it is present. Then we are going to uh, load the model by calling as joblib.load, and we'll specify our save path. Then I'm going to say print model has been loaded. And once that is done, I'm going to say return model loaded. So this is going to return the deserialized model. So what we have done as part of our implementation is we have created our training pipeline. We have created our configuration file, and inside this data handling.py, we have created three custom function, one which would help us to load the data set. The other one is for saving the pipeline. And we have also mentioned one more thing that's called as the loading the pipeline. So if we come back, see this is going to load the data set, and from the loaded data, so we'll separate the X and Y. And from here, we are so here from here, we have created something which will save the pipeline. Now, what is left for us is to be able to perform the classification, we'll have to create something inside this pipeline.py. So from this pipeline.py, we'll have to create this classification model, and post that we'll have to perform the fit. So that's the expectation right here, guys. So we'll continue further of this implementation in our next session, guys. So with this, we come to the end of this today's session on the implementing the MLOps project live in a hands-on manner. So folks, I hope you're enjoying this live session. So I'm sharing you the link over here. So do check out this link to download the to download the sessions recording at a later point as well. So by visiting the site, you can access the sessions recording. Okay. And also, guys, if you're someone who wants to take your learning journey in the MLOps to the next level, do check out the MLOps bootcamp from Manifold AI Learning. So you can check out the MLOps bootcamp from Manifold AI Learning. And apart from that, there are other courses as well, which is worth checking out. The recent one is the LLM Ops course, where you will learn how to implement the large language models in the production environment. And I want to share one more update for the learners of this LLM Ops. We are going to add new 2 to 3 chapters, especially around the RAG architecture. So how to make use of the RAG concept in the LLMs, that is in the large language models. So those chapters will also be upgraded for free for all the learners. Now if you're someone who is new to the RAG concept and the large language models prompt engineering, how it works, I highly recommend you to check out the course, guys. And tomorrow there's an exciting webinar. So tomorrow's webinar is about how you should perform the preparation for the NVIDIA Mastering the Generative AI with LLMs. So it has been a wonderful day today for me. So I have cleared this NVIDIA Generative AI large language models. So I'll be sharing you my experience and how you can prepare yourself for this NVIDIA certification. Okay, so this is the certification, that is generative AI LLMs. So this is the examination. So it was 50 questions and 1 hour. So I was able to successfully clear the examination, guys. And I'll be talking about it in our next session as how you should be preparing yourself if you're someone who is aspiring to get certified from NVIDIA on the generative AI. Okay, so we'll be discussing in depth in tomorrow's session. Don't miss out. So let me share you the link for the learners who wants to register yourself right away for tomorrow's free webinar on the same. So I've shared you the link in the chat window, guys. So do check out the same. All right, guys. So with this, we come to the end of today's session, guys. And I hope to see you next time. So take care, everyone. Okay. Thanks a lot, everyone. Take care. Bye.